Okay, so today we are going to learn our very last factoring method. So we're learning our very last factoring method, and then the next lesson is going to be just getting a bunch of problems and figuring out which method to do when. Okay, so our last factoring method is a little trick. It's called a perfect square trinomial, and we have a rule for it. Okay. Oh my goodness. Okay, so it's called a perfect square trinomial. It looks like this: a squared plus 2ab plus b squared. Those are all going to be numbers. The way we factor it is we take the square root of a squared, that gives us a. We take the square root of b squared, that gives us b. And we keep the symbol that's in the middle, and the whole thing becomes squared. We're going to practice this. It also works for subtraction, so we could also have a squared minus 2ab plus b squared, and that's going to give us a minus b, all of that squared. Okay, this is a trick for a specific type of problem. So I'm going to show you what the actual problem looks like, but I want you to write down the rule first. Okay, so let's look at this going backwards, because Marcus asked a good question. Is there a reason why it's 2ab? So let's look at a problem that looks like this. We've seen stuff that looks like this before. Do you guys remember this thing? X plus 3, all of that squared. So let's actually FOIL it out and see what we get. So in the column, just write the little scratch work. How did I FOIL this out to begin with? What did I have to do first? Good. You have to expand it. X plus 3 times x plus 3. X times x gave me x squared. X times 3 gave me 3x. 3 times x is 3x. And 3 times 3 gave me 9. Combine like terms. So what would I get as my answer? Okay. This thing has 3 terms, so it's called a what? Trinomial. But why is it called a perfect square trinomial? Look at our original problem. X plus 3, all of that squared. Is this a perfect square? Yeah, because it's the same thing multiplied by itself. So it's called a perfect square trinomial because our answer is a trinomial and our problem is a perfect square. So why is it 2ab? What's a in this case? X. What's b? 3. A squared is what gave me the x squared, right? B squared, or 3 squared, is what gave me the 9. What's 3 times x? 3x. 3x times 2? 6x. Why is it times 2? Because we will always get 3x plus 3x. Okay? It's a little tricky. Let's start with an easy one. So example 2, or 1, sorry. X squared plus 6x plus 9. That should look familiar, right? Let's do a test. I think it might be a perfect square tri. That's how I abbreviate it. So I'm going to write next to it perfect square tri. So I think it might be a perfect square trinomial. Why? X squared, is that a perfect square? Yeah. 9, is that a perfect square? Yes. So our first and last term will always be a perfect square if it's a perfect square trinomial. So I think it might be what? What's the square root of x squared? X. What's the symbol? Plus. What's the square root of 9? 3. And then we write all of that to the second power. Let's do a quick test. 3 times x gives me 3x times 2, 6x. So we got the right answer. So that's how you check it.
So you don't do anything with 6 until you're like you're finished.
Pretty much that's all I have to do for a
Yeah. And so Omar asked a great question, guys. He said, would you get the same answer if you do the diamond method? Let's check. If I have diamond, 9 goes on top, 6 goes on bottom. What are the two numbers that multiply to 9 and add up to 6? 3 and 3. So that would give me x plus 3 times x plus 3, which can be simplified to x plus 3 squared. So we do get the same answer. Okay? So you can do the diamond method. The reason why I'm showing you this is because you will see some problems that would be bottoms up otherwise, and I don't want you to have to do that many steps. Okay, so what I want you guys to do right now is let's see if you can figure it out on your own. Example 2. I'm going to leave example 1 up. Try it in your notes. Is this a perfect square trinomial? All right, guys. Is this a perfect square tri? Yeah, so I'm going to write it next to it. I just think it's good practice to write down the method. Okay, so if it's a perfect square trinomial, that means I'm going to have one set of parentheses and all of it's going to be squared. What will go in the first spot? C. What will go in the second spot? 5. And what's the symbol in the middle? This is a plus again. Let's do a check. What's 5 times C? 5C times 2? 10. What's another way that I can check my answer? Box or FOIL. So we can do a check. C plus 5 times C plus 5. Write this down. What's C times C? C squared. What's C times 5? 5C. 5 times C? 5C. And 5 times 5? 25. What's 5C plus 5C? 10C plus 25. Did we get the right answer? Yes, we did. Make sense? Okay, so this is a shortcut. So if you ever happen to notice that the first term is a square and the last term is a square and it's a trinomial, meaning how many terms? 3. Try for a perfect square trinomial. Okay? Okay, guys, Marcus asked a good question. If we are supposed to check for all of these methods in that order, why would I ever bother with a perfect square trinomial? Well, let's look at number 3. I have 25g squared minus 30g plus 9. First thing we should always look for is a what? GCF. Do you guys notice any GCFs in here? No. It's obviously not a difference of 2 squared. There's 1, 2, 3 terms. It's obviously not a diamond method. We think it's bottoms up. If we do bottoms up, we would have to multiply 25 times 9, which would give me g squared minus 30g plus, what's 25 times 9? 225? Is that what you got? Okay, so can you find the numbers that multiply to 225 and add up to negative 30? That's going to be a lot of work. Okay, you can do all that extra work if you want to, but what do I notice? Is 25g squared a perfect square? Yeah. Is 9 a perfect square? Yeah. Let's go for a perfect square trinomial. Okay, so if I'm going for a perfect square trinomial, I would have a parentheses squared. What's the square root of 25g? 5g. What's the square root of 9? 3. What would the symbol in the middle be? This time it's negative. And that would be my answer. A lot faster than bottoms up, right? Let's do a quick check. What's 5g times 3? 5g times 3, guys? 15g times 2 gives me 30. Now let's actually do the full check. Let's do the full check. So everyone needs to do this check in their notes. So we expanded it out. 5g times 5g gives me 25g squared. 5g times negative 3 is negative 15g. Negative 3 times 5g, negative 15g. And negative 3 times negative 3, positive 9. What's negative 15 minus 15? Negative 30. So that's going to be minus 30g plus 9. Is that what we started with? Yes. Faster than bottoms up? Yes. Okay, so if you see something that looks like bottoms up, but you notice that the first and last term are perfect squares, go ahead and do a perfect square trinomial. If you can't remember the rule, go ahead and do bottoms up. You'll get the same answer. Okay? It just might take you longer. So let's try the last one. I'm going to leave this one up. Okay, so very last one. 64r squared minus 144r plus 81. Is this a GCF? Is there a GCF in here? No. Is it a difference of two squares? Definitely not. Is it a diamond method? No. Is it a bottoms up? Yes, could be. What do you notice, though, about this whole thing? It's a perfect square trinomial. Do you see why it's easier to do perfect square tri than bottoms up in this one? I really don't want to multiply 64 times 81. Okay, so let's do a perfect square trinomial. Set up your parentheses, squared. What goes in the first blank? 8 what? 8r. What goes in the second blank? 9. And what's the sign? Minus.
Why is it minus?
Because this one's minus. Okay, so then how would I check it, guys? We always have to do a check. Expand it. So 8r minus 9 times 8r minus 9. 8r times 8r? 64r squared. 8 times negative 9. Negative 72r. Negative 9 times 8r. Negative 72r. And negative 9 times negative 9? Positive 81. What's negative 72 minus 72? Neg 144r plus 81. Is that what we started with? Yes, it is. So we factored correctly. So now we have a shortcut. Perfect square trinomial. So if you can use diamond method, like in examples 1 and 2, go ahead and use diamond method. It's sometimes pretty quick for us. Just be able to recognize that x plus 3 times x plus 3 is x plus 3 squared. But if you see something like examples 3 and 4 that look like bottoms up, go ahead and check for perfect squares first, because that will make your work a lot easier. Especially, big hint for the test and STAR testing, if the numbers are outrageously large, like 64 times 81. Do you think that I really expect you to be able to multiply all of that and then do diamond method on it? Check for perfect square tries, okay? Because it's almost always going to come out to be perfect squares. Got it?
Got it.
Okay.